Hey everyone, welcome to The Explainer. It's pretty wild when you think about it. Your brain is literally the most powerful computing machine in the known universe, right? And yet, we were all born without an instruction manual for the thing. We spend years trying to cram data, languages, and facts into our heads, but let's be honest, most of us are using totally outdated, inefficient software to do it. Well, today, we're going to change that. We are going to decode the exact mechanics of how human memory actually works, and I'm going to give you a step-by-step blueprint to basically hack your own retention. So tell me if this sounds familiar. You're super motivated, you sit down with a vocabulary app to learn a new language, or maybe you're studying for a big certification exam. You stare at the screen, you repeat the words, you feel like you've completely nailed it, and then the very next morning you look at that exact same list of words, and your mind is just a complete, frustrating blank. The information just vanished as if it was never even there. Why does our brain betray us like this? Okay, let's dive right into part one, the science of forgetting. To figure out why things just vanish from our heads, we really need to look at the core problem with how we've all been taught to learn.
Think about it. The traditional way of studying is basically just force-feeding our brains abstract information. We're asking a biological system that was built for a rich 3D environment to suddenly care about flat, lifeless data. Notice the huge difference here. On one side, we've got abstract words, just letters and symbols printed on a page or a screen. These are incredibly weak, fleeting signals for your brain. They don't smell like anything, they don't have texture, they don't have any weight. But on the other side, we have physical reality. Your brain is an absolute master at navigating physical space and real-world objects. When we try to memorize abstract symbols, those memory traces are incredibly fragile. But when we experience physical reality, that memory leaves a deep, lasting imprint.
And that brings us to our first huge shift, part two. Objects outlast words. If you actually want a memory to stick around, you've got to translate that flat data back into the real, physical world that your brain genuinely cares about. Let's break it down. When you just read the word apple, it only lights up a super specific, tiny part of your visual and language centers. It's a really shallow cognitive footprint. But seeing a physical, 3D apple, that engages entirely different, far more robust neural networks. You instantly process its volume, the way light hits its curved surface, its distance from you. You're basically creating this multidimensional mental image that is incredibly sticky. And the data backing this up is honestly staggering. When tested after a few days, you're roughly 3 times more likely to remember physical objects compared to written words. 3 times! Just by shifting the input from a flat word to a physical object, you are completely supercharging your attention. Imagine applying a 300% boost to the very next subject you try to learn, simply by visualizing the real-world objects instead of just staring at their written names. But hey, we don't just live in a world of static objects sitting around. So let's move to part 3, memory in motion. Our brains are deeply, fundamentally wired to track and remember movement. Survival in the wild depended on noticing what was moving and remembering the exact actions we took to interact with our environment. And this brilliantly illustrates exactly why traditional studying completely fails when we're trying to learn actions. Look at the difference here. Reading the verb to jump on a screen versus physically standing up and actually doing the movement. When you just read the verb, it's completely abstract. But when you physically act out a motion, your brain's motor cortex just lights up. You are completely overriding that weak visual stimulus of the text with this massive flood of physical feedback right from your own body. In fact, science shows that physical actions can boost your memory retention by up to 36%. When you perform an action, your body is literally creating these tiny motor memories. You're sending signals through your nervous system that cement the concept directly into your neural pathways. You aren't just learning it with your mind anymore, you are quite literally learning it with your muscles. Now, let's step into some fascinating psychology in part 4, the detail advantage. How does the actual shape of what we're looking at dictate whether we'll remember it tomorrow? Well, it turns out that our eyes act almost like hands. They physically trace shapes and boundaries to feel out an object and lock in its memory. The golden rule here is pretty straightforward. Your brain totally craves complexity. A plain, boring, homogeneous surface, that is the absolute enemy of memory. There's just nothing for the mind to grab onto. But jagged, complex, varied details, those are your memory's best friends. The more intricate the boundaries of an object or an image are, the stronger the mental anchor. Now, what's really interesting here is how our eyes behave completely differently depending on the shape in front of us. When you look at a plain gray circle, your eye just takes it all in instantly, right? It's a smooth boundary, you passively glance at it, and your vision just glides right off in a split second. but look at a sharp, jagged star. Your eye doesn't just glance at it, it actively explores it. It darts from point to point, traveling deep into the angles and all the way out to the tips. So let's walk through exactly why that mental exploration is essentially a superpower for learning. First off, your eyes actually physically trace those complex borders. Second, and this is wild, that tracing action actually builds an invisible motor memory. Just like jumping helps you remember the verb, the microscopic muscle movements of your eyes darting around the star's points build a physical memory of the shape itself. Third, all this detail forces your attention to linger. You can't just brush past it. And finally, because your attention is held captive by all that complexity, it completely eliminates mental fading and blocks out distractions. You're forcefully writing that data directly to your brain's hard drive. Okay, so we've talked about objects, motion, and visual complexity. Now we're at the climax of the explainer. Part 5, the association superpower. This is the ultimate memory hack that combines everything we've talked about into one devastatingly effective technique. It's a concept called indirect association. The definition is simple, but it's a real game changer. It's the act of linking an unknown, brand new concept to something completely familiar to build a permanent mental bridge. Think about when you have to create a really strange, complex new password. If it's just random letters, it's gone in seconds, right? But if you mentally associate that weird string of letters with a vivid, highly detailed childhood memory, say the name of your first dog and the street you grew up on, you instantly build a bridge. You attach the new, weak information to an old, incredibly strong memory, and suddenly, it sticks forever. You really have to remind yourself of this. An unanchored fact is a lost fact. Raw, isolated data fades incredibly fast because it's just floating freely in your mind with absolutely nothing holding it down. But connected data stays locked in. Your brain fundamentally requires these mental bridges to hold on to things long term. If you don't tie a new fact to something you already know, it's just going to drift away by morning. Let's look at how this builds over time. If you just try to brute force memorize raw data with rote memory, you might hit about 63% retention on day 1. But by day 15, it plummets to a dismal 19%. Almost everything is gone. Now check out the associated memory. When you use mental bridges, you start it at a super impressive 82% retention on day 1. And fast forward to day 15, you're still holding on to an incredible 64%. The associated memories stay incredibly stable over time. Guys, that is the difference between cramming something for a test tomorrow and actually learning it for the rest of your life. So the crucial point is, you don't have to be at the mercy of a leaky memory anymore. Let's bring this whole explainer together into the memory hacker's blueprint. This is a practical, actionable toolkit that you can use literally the second this video is over. All right, here is your step-by-step instruction manual to completely upgrade your learning. Number 1, when you are learning new words or concepts, visualize the real 3D objects. Do not just stare at the written nouns. Picture the weight, the color, the actual reality of it. Number 2, when learning actions, act out the verbs with your body. Get those motor memories firing. Number 3, seek out visual complexity. When you study a diagram or an image, force your eyes to trace the jagged edges and the intricate details so your attention actually lingers. And number 4, always create weird, strong, highly detailed indirect associations. Anchor every single new fact to something you already deeply know. By doing all this, you're no longer just passively reading words off a screen. You are literally hacking the evolutionary biology of your own mind. You've got the cognitive superpowers now. The only question left is, what will you learn next, now that you finally have the manual? Think of a topic you've always wanted to master, take these tools, and go test them out for yourself. Thanks so much for joining me on The Explainer, and I'll catch you in the next one.